Okay, video recording failed today, and now I'm here after class, and I will still talk a little bit about the code, what we have done today, but it's going to be a very short thing. So the application is now done, this portal opening effect. You have to draw a circle in 2 seconds. So if you do it in 2 seconds, and if your roundness value is good enough, then you will get this kind of portal opening effect there. And the percent on the top tells you how round is your shape. In the code, we have overlapped the two canvases. So initially we had this two canvas setup where we have the particles drawn on the right and the person's camera on the left, but now we overlap them like this, so we actually have layers. We have 2 layers there. What has happened in the code is mostly this Animate particles function. So this one is going to draw particles at the tip of the pointer, or more or less the end of the polyline that you are drawing. So while you are drawing things, this line appears if I leave that code uncommented, and on the tip of that line particles are going to be generated, and they are shooting in random directions. If you complete the game, like now, particles come from all the points of the polyline, so not just from the tip. And this is what this code is doing here. If it's not done, then only the tip. Otherwise, from all of them, you create new particles. I remove the particles that are becoming transparent. So the particles have a fixed lifespan. They stay there for 10 frames. If I look in this particle class, it's initialized with 10. It gets less and less, and when it becomes 0, I remove them from from the computer's memory. Otherwise, it will continue to use memory even though they are moving out of the screen or they are transparent. To calculate the roundness, we use the formula where we calculate the area of the polygon that is drawn and divide it by the maximum possible area, which we have discussed on this slide here. So the circle will give you the maximum area. The polygon length and the area for the polygon are, the length is obvious, it's just the distance between every 2 points of the polygon added up. The area has a more complicated function, and if you go to this link, you will have a nice interactive application showing you how the function works. Then every time the pointer is detecting that it moves, it checks the roundness, and if the roundness is going to be greater than 95%, then you are done. You complete the game. We also update the title to put there this percent value to know how good your score is, and we remove the event listener so that the application doesn't update anymore. I mean, you can't draw anymore after you finish the game. Okay. And the last thing is when you finish the game, in addition to all those other things like more particles, we reveal the image. So we take the polyline and clip inside it according to this path, and then we draw the image only inside the boundary defined by the polygon. So that's more or less it. You can refresh the page and play around with it. I'm going to hide now this black line so that it becomes harder difficulty. If you don't see that line, it's actually harder to make the drawing. So draw polyline function, I will just comment it out so it's more difficult. And yeah, now it somehow looks like just particles are coming out, and then this image of Mount Everest is inside the portal. And the game is over and you have to refresh the page. It's also possible, I remind you from yesterday's lecture, that we have this initialize video function. So instead of running it with the camera footage, you can run it with video footage, like this one that was recorded by me the other day. Okay, so this was in short what we did today. I hope it doesn't disappoint too many people. If you missed this course, then check the source code, ask from other people, and you can visit me also for specific things. But the most important things were already discussed yesterday. So today is more or less putting the application together. So see you.